So today into this video, we are going to focus in binomial distribution. So since we know that binomial distribution is one of the distributions among distributions of probabilities, precisely discrete, Poisson, and others. So today let's focus on binomial distribution activities. So there is a formula that we must know. These different distributions, they have their own formulas. So the formula of binomial distributions are here. I wrote them here. So in binomial distribution, mean is also denoted by mu. But now here, there is a different case. So n, wherever you see n in in binomial, automatically you must know that we are talking about the sample space. N in binomial distribution denote the sample space. P in binomial distribution denotes the probability of success. Wherever you see P is the probability of success. Wherever you see Q, Q is the probability of failure in binomial distribution. Now, our standard deviation is denoted by N times P times Q in our standard deviation, which is the simple mean times the probability of success times the probability of failure. From there, our variance is going to be the square root of the standard deviation. So now, to understand this thing better, here is the question. Here's the statement. They say a textile firm found from experience that only 20% of the people applying for a certain stitching matching job are qualified to work. Our information is that only 20% are qualified. Then they say 5 people were interviewed for this work. So from this statement, let's first write our major keys that we are going to use to answer the questions. If you want to be successful in probability, make sure that each and every time you read a statement, you pick the keys that you will use to get the answers. From there, our first key is that 20% of the people are qualified. Then this 20% is probability of P, which is the probability of success. When we know that 20% have qualified, then we know that is the probability of 0.2. Then automatically we know that 80% of them, they have failed, which is the probability of failure. That's why we said Q automatically is equals to 0.8. If this statement they said 0.8 over 80% has failed, how many percent automatically has passed? We know that no, it's 20%. 20% is for success. That's why here we said 0.8 is for failure. It's the probability of failure. Now they said 5 people were interviewed. Then that means our sample space is 5. That's why we said N is equals to 5. Now, before we continue, what you must know is that P plus Q, they must be equals to 1. And P is equals to 1 minus Q. If you are not looking for failure, automatically you are looking for success. If you are not looking for success, automatically you are looking for failure. This is same as complementary rule. If you did complementary rule among the rules of probability, we know that Q is equals to 1 minus the probability of success. Automatically we are looking for failure. Now here comes the first question. See, find the mean and the standard deviation. Here is our mean. Don't forget that we said the formula of mean is the sample space times probability of success. That's why here we said 5 times 0.2, which is equals to 1. This is our mean. From then they said the standard deviation. Don't forget that our standard deviation is equals to sample space times the probability of success times the probability of failure. That's why here we said 5 times 0, 0.8 times 0, 5 times 0, 0.2 times 0, 0.8, all of them, the product was 0, 0.8. Then our 0, 0.8 is our standard deviation. These are the first major things that we must know in binomial distribution. Here comes the question. What is the probability of finding at least 3 qualified persons? At least 3. Let's highlight this statement. At least 3. At least 3. Now, we know that no, the probability that we are looking for is at least from 3 and above. And we know that our sample space is 5. That means we are going to say the probability of x greater than equals to 3 is equals to the sum of the probability of x equals to 3 and x equals to 4 and x equals to 5, since we know that our sample space is 5. Now we want at least 3 people that have qualified out of these 5 people. That's why we started from 3 to 5. At least 3, it means greater than equals to 3. Wherever you see at least 3, then that means they say greater than equals to 3. If they said at least 4, it was going to be greater than equals to 4. So now we start. Here is the formula. Here is the formula that we must use when we are looking for the probability in binomial distribution. N, is denoted by n. This n is our sample space. Don't forget this c on your calculator. This c on your calculator, you are going to press shift and division sign. When you press shift and division sign, you are going to get this sign here. From there, this is our x. P here is the probability of success. Now times 1 minus p. This is probability of failure. 1 minus p. You may write q or you may say 1 minus p. There's no problem, but it must be to the exponent of n minus x. What you have to know here is what I tell you, what I highlight here. 1 minus p in this formula. If you don't want to write 1 minus p, you may write q, because we said q is equals to 1 minus p. So these are the formulas that you must know. These things are the basics that you must know when you attempt binomial distribution. Now don't forget that I said when it comes to this c, you just press shift, then you go to division sign on your calculator. Now what is the probability of x equals to 3? Wherever there is x, you are going to put 3. Wherever there is x, we put 3, since they say what is the probability of x equals to 3. Because we said now we want the probability of at least 3. That means x is greater than or equals to 3. We start by 3. That's why we said 5 into c 3 times 0, 2 to exponent 3 times 1 minus 0, 2 into the exponent 5 minus 3. Our answer was 0, 0.0512. Now, before you cancel that whole answers, the whole set that you have punched in your calculator, now you just go back into the same set that you have entered. Where there was 3, now you substitute by 4. You replace 3 by 4. That's why here we said 5c4 times 0, 2 to exponent 4 times 1 minus 0, 2 to the exponent 5 minus 4 is equals to 0, 0.0064. Finally, our last number, our last expected event, the probability of x equals to 5. Then we said 5 into c5 times 0, 2 to exponent 5 multiplied by 1 minus 0, 2 to exponent 5 minus 5. Therefore, our answer was 0,0032. This is our answer. But no, guys, sorry, this set here is not our final answer, because they say they want the probability of at least 3 qualified people. Now we add all the sum. Now we want the sum of 0,0512 plus 0,0064 plus 0,00032. Now our sum was 0,0579. This is the final answer. This is the answer that they're looking. But if you just put these things here separately, then you don't add them, you will be marked wrong, since they are not looking for the probability of 3, the probability of 4, or the probability of 5. What they want is at least 3 have qualified. So you add these probabilities, then our sum was 0,0579. Now, secondly, what is the probability of finding not more than 2 qualified persons? Now, understand this statement, guys. They say not more than 2. Let's highlight this statement. Not more than 2. There is something that here you have to understand. When they say, guys, not more than, they don't mean less than or equals to 2. Because many, when we read this statement, they will think, maybe they say less than equals to 2. You are going to get a wrong answer. When they say not more than 2, we are going to apply complementary rule. We know about the complementary rule among the rules of probability. Here, that's why we apply it. When they say not more than 2, simply they say you subtract the probability of x is greater than or equals to 3. That's why here we said the probability of x is greater than 2. We denoted it by this complementary sign, not more than 2. So when we say not more than 2, we mean not more than 2. Simply we mean not the probability of x is greater than equals to 3. That's why here we said 1 minus the probability of x is greater than or equals to 3. We subtracted it from 1 because we want the probability of not more than 2 qualified people. Then our probability of x is greater than equals to 3 was 0,0579. That's why here we said 1 minus 0,0579. When we subtracted it from there, when it is 1, subtract 0,0579, our final answer, let me calculate it here. 1 minus 0,0579. Our final answer was 0,9421. This is our final answer. 0,5421. 0,421. This is our final answer. When we say the probability of not more than 2 that are qualified, then our final answer we expect 0,421, 0,9421. So guys, that was it. This one here, it was little tricky because many people I know, when you say not more than 2, or we know automatically that means it's less than or equals to. For you to prove what I'm telling you here is truth, our answer, if you can add 0,9421 plus this answer here, your answer must be 1. Your answer must be 1. 0,9421 plus 0,0579. Here our answer is 1. Then it tells you the answer that the way we did it here is correct. But if you say x, the probability of x less than equals to 2, the answer that you are going to get here, when you add it with this one, it will not give you 1. Then you know or it is wrong because it is not the conditions of the distributions. The condition of the distribution that all the probabilities, when we add them, they sum up to 1. So thank you very much, guys. If you can know the conditions of this binomial, then you will be successful. Some of the conditions, one of the conditions said is that all P and Q are independent. They are independent events. They are independent events. So thank you, guys. You are free to comment. If you didn't understand somewhere, feel free to comment, feel free to ask. Thank you very much.